So in year 4, we've had quite a few parents asking about how we teach multiplication. And a few of the comments that have come up is that it's very different to how we learned multiplication all those years ago when we were at school. And so I thought I'd do a little video just to show the progression of multiplication and some of the different approaches and strategies that we use in the classroom. The main thing to talk about is the difference in mathematical teaching nowadays. So we run through this idea here. When I was at primary school, we learned in a very abstract manner. That's just using numbers. And we were taught a method, and we were expected just to replicate that method over and over and over again until hopefully some understanding embedded in there. However, at the moment, we follow the mastery approach of mathematics, and the idea is that a child who uses concrete resources, so things that they can feel and touch, gains a really good understanding of concepts, which then falls into their use of pictorial mathematics. So they might use pictures of those resources or pictures of different things. And then with both of those, with an experience of both of those, then a child will have the capabilities of understanding the concept in a very abstract sense, so just using the numbers. And with the use of all three, we can promote good fluency of methods. So we will see that as we go through the different methods. So the first way that we introduce multiplication is through the array here. So we look at 6 times 4 here, and the children will have counters out on their desks and be making these with different resources using the concrete method, and then they might draw them in their books using a pictorial method before we just look at the abstract, which is just the numbers there. So the idea here is that the children are very clearly seeing what 6 times 4 means. It's 6 rows of 4, or it can be 4 rows of 6 as well, so that they can physically see what multiplication means and how big a number can get when you multiply. So that would be the first way that we introduce multiplication, because we need the children to realise that multiplication is slightly different to addition. Multiplication is groups of and lots of, and the numbers can very quickly get quite large when multiplying. So from there, we then progress on to place value charts here. We start looking at 2-digit numbers multiplied by a single digit. And again, we do use counters, and we do that physically in the classroom. But we then start organising them into these columns here. So we'd have a look at 26, and we make 26, and we talk about how 26 times 4 is 4 lots of 26. So we need to make 26 4 times, and the children will have to draw them out or get the counters out and line them up. And again, that's just reinforcing the fact that multiplication results in a much larger number than just addition can. So we then count them all up, and that's how we'd find the answer with the place value chart. And we can extend this with columns of 100 and 1,000. And we talk about 26 being the same as 4 times 26. And then we might talk about how there could be a difference if we're organising a birthday party. Do we want 26 tables and each table to have 4 balloons on? Or do we want 4 tables and each table to have 26 balloons on? So there is a difference in meaning there, and we're starting to explore that, but again in a very visual or concrete way with the resources. It's a way of turning this very abstract idea and trying to understand the concept behind it. So from there, we will then move to a more abstract approach, and we'd look at partitioning. Partitioning, just a fancy word to say split. So we take 26 times 4 and we're going to split it into 20 times 4, so we're taking the tens out of here, and we split it into 6 times 4, and we do those individually using this pattern here. So we'd say, right, what is 2 times 4? That equals 8, so 20 times 4 must equal 80. And then we write it out, and we start then introducing this idea of columns method here. And if you notice with the array and the place value chart, they are all about neat columns in both of them, because we're building up to that column method that we learned when we were at school as well. So we do 20 times 4, and then we do 6 times 4, and then we find the answer out here. And this is where some of the children whose multiplication facts aren't as strong can find it tricky. Now in school, when learning the methods and exploring the concept, we do give the children multiplication grids. We don't see it as a form of cheating. We just think actually the method is important here. So we give them the multiplication grid so that they haven't got to worry about getting those times tables wrong there. So that's how we would then move it on. Now this becomes important later on. We explore the idea of partitioning with the number line method here. So again, we still partition, but we just want to show it in a number line method here, which is just a slightly different approach, where we split it up. Instead of going straight for that 20 times 4, we split the first number lines up into tens, because multiply anything by 10, it becomes easier. We call it a safe number in school. So the children will start with 10 times 4 will land us to 40, and then another 10 times 4 because it's 20 gets us to 80. If that was 36, there'd be 3 jumps of 10 times 4. And then we do the 1 times on the end, 6 times 4 equals 24 here. That does require the ability to do some good mental maths there, which can sometimes be the obstacle to that method. We then might move some children on to doing, instead of doing the jumps of 10, if they really understand this pattern here, then it's quite an easy jump on the number line to then go on to doing the 20 times 4 in one jump, rather than breaking it into the jumps of 10 there. So then we start looking at a completely abstract idea of looking at the expanded column method. So you might have learned multiplication through the column method, and the expanded column method is how I learnt it, but I didn't have all of this knowledge beforehand. So sometimes if I'd made an error in a column method, I wouldn't have realised I made an error. And this times in by 10 always threw me, because I don't think I had that concrete and pictorial knowledge to know that this digit here stands for a 10. That's 2 tens, so it must be 20. So here we just write out the multiplication in a column method, and then we always do the ones first, so it's 4 times 6. I like to write it in brackets just so the children remember what stage they're at, and 24. And then the next one down, we've got that 4 times 20, which would get me 80, and then I'm going to add them together to get the answer. Children quite often enjoy that, but they can get the brackets in the wrong places, or the numbers don't quite match up in the right columns. So it's again all about being neat and tidy with your maths jottings to make sure that you don't get confused at all. We then move on to just the column method here. So without the brackets, and it's a completely abstract idea, but this requires a real sound knowledge of that 2 being 20 and of the exchanging. So here we've done 4 times 6, which gives us 24. So the 1s has gone in and that 4. We've then exchanged the 2 because we know there's going to be those 10s multiplied. So I've done 4 times 20, which 4 times 20 gives us 80. We've got 80, add the 2 10s, which gives us 100. Okay, so that's 104 there. But again, all of that work that goes into getting here, because children must know that they're multiplying the 10s. We want them to be able to visualise what they're doing in their heads, and to understand that if they're multiplying by 4, this 26 is going to become eventually a much larger number. And that exchange is what, and this element here, is what throws children at this method. Back in, like I say, when I was at primary school, I was just taught this method, and I don't think I had any conceptual understanding of what was going on. I just knew the method and I knew how to replicate that method. So if a question came with a missing number, or a question came asking me to explain anything, I think that's where my downfall was. So we put in all that concrete and pictorial before we get to complete abstract, so that children can visualise what's happening here whilst they complete it.